So our discussion for today is the theoretical part of the input-output analysis, or the IO model. Uh, and then later on, we'll discuss case one or an example. And then on Friday, we'll talk about, we'll get data from PSA to obtain input-output table, and then also discuss the closed economy using the IO model. Okay. To start, let's discuss briefly who Vasily Leontief is. So he published the Review of Economics and Statistics in 1936, which is uh, a quantitative input-output relations in the economic system of the United States. Now, at first, his work was not widely acclaimed, or was not there was not much in terms of there. It did not attracted the audience, or the audience around that time, because it was also in the midst of the Great Depression in the 1930s. Now, in the same year, 1936 class, John Maynard Keynes published the General Theory of Employment, Interest, and Money, which was focused on the problems of chronic unemployment in the capitalist economics of that day. So, but again, the importance of his contribution was acknowledged later, uh, because he won the Nobel Prize in Economics in 1973. Now, Leontief class was not particular with solving the equilibrium values, or was not he was not interested in solving for that optimization value, or in doing economic analysis. But what he is particular with was how components, or how parts of the economy fit together and also influence one another. So because of this insight, much of his work on the input-output model was on the interrelationship, or the how sectors are interdependent with one another. Okay. Now, the Leontief's input-output analysis tries to answer this question: what level of output should each of end industries in a particular economic situation produce in order that it will just be sufficient to satisfy the total demand of the economy for that product? So again, the insight that we'll be getting from the input-output analysis is not particular on optimization value or getting the equilibrium values, but rather that specific production level which is consistent with inputs and output. Okay, so much of the discussion today is again looking for that input requirements that is consistent, that is equal to the total output in each sector of the economy. We'll also start with the IO model basic assumptions, just to guide us class on, uh, or just to also to simplify our study. So number one, there are n interlinked industries. So as you all know, there are a lot of industries, or a lot of there are three big sectors, but there are subsectors below it. So what I mean to say is that in our study, to simplify, we'll only be dealing with three sectors, mostly agriculture, manufacturing, and services. But then again, we also acknowledge na in real data, we have subsectors, and each subsector would also produce a number of commodities. Which brings us to the second basic assumption of this model, that is each industry will produce one single good. Now, this tells us kasi that the end sector and end kinds of commodities are in one-to-one correspondence, meaning that the sector will be producing the ith good in the ith good denoted by J. We need to do this, we need to limit our study in one homogeneous good, because as I mentioned, there are sectors, and each subsectors class, if you look at the industry classification in PSA, and dami din siyang subsectors, and each subsector will produce a lot of goods. So for example, in agriculture, it will only produce one good. In manufacturing, it will only produce one good, and also in services, it will also produce one good. So the correspondence in this case would be a 1-to-1. Okay, one sector, one good. The third one, the, the third one is each industry will use a fixed proportion technological progress. Now, in this case, Cass, if you're still familiar with this coefficient later on, we call that one technical coefficient. We also can call that one input coefficient. But then again, I would be your input, J would be your output. Okay. So AIJ here would be considered as our fixed recipe. So pag sinasabi natin in terms of production kasi, we say that the production function will yield a fixed technical coefficient, or it will yield a constant returns to scale. So the sector here will use strictly in fixed proportion. Okay. We'll use this. This one here is important, especially when we are building the technical coefficient matrix later on. Okay. So again, let me summarize the basic assumptions. Uh, there are three. There's three sectors that we will do. That we'll study for this course. And then each of the end sectors will produce a single kind of commodity. So it's a homogeneous good. And the third one is each industry will use a fixed proportion technological progress. Okay. Now the input output model. Now again, class, the key idea about the input output model is that there is interrelated industrial sector. So when we say interrelated, it means that an industry's output is used as an input in some other industry's production process. This only tells that, like for example, if we're dealing with three sectors: manufacturing, agriculture, and services, it means that the agricultural sector will use some inputs from the other two sectors, which is manufacturing and services, and it could also use its own input to produce an end level production output. Okay, so another thing as well is that what we're the problem or what we're trying to solve here is we're looking for that production level for each industry that is just sufficient to supply the demands from industry and consumers alike. So in that case, class, we will treat the IO model as uh, correction, correct, no, correct output levels equal or consistent with all the input requirements. So that's why we are calling it input output model, because in that case, the input should be equal to your output. Okay. And why it's the best tool to use, especially in production planning, because it can correct output, it can correct either of these levels. For example, if this is greater than if the output is greater than your input, you will need to manipulate or you make adjustments in the production level, because our assumption in the IO model is that these two, your output level should be equal to the requirements used in that production, which is again the input. Okay. Now, also, the Leontief model is used in these two analysis. We have open and closed Leontief model. So when we're dealing with an open Leontief model, it means it's a sector that lies outside the system. It also indicates that it finds the amount of production needed to satisfy an increase in demand. Now, later on, class, you will also know that in the open Leontief model, we have other sources in order to produce we have other sources, okay, other sources in order to produce an output. Okay, so these other sources that might not be coming from the input use produced in agriculture, manufacturing, or services. It could be labor or capital. Okay, but then again, these are the sources. These are exogenous to the model. Okay, when you have a closed Leontief model, this is the sector is absorbed into the system as just another industry and deals only with the income of each industry. So if we assume that we only have three sectors in the economy, then the input should only be coming from the three sectors. Okay, or the income or the three inputs or outputs should the three outputs should only be coming from the inputs of the three industries or the three sectors. Three sectors. So again, agri, manufacturing, and also services. It would be strictly coming from these three sectors. In this case, kasi class, in the open Leontief model, other than the three sectors, okay, other than the three sectors, we are also using other sources, such as uh, example, labor and capital to produce or to satisfy if ever there is an increase in demand in that economy. Okay, so you see the distinction other than the ones I define here. So again, this is what differs in an open and closed Leontief model. Okay, now let's also discuss the general form when dealing with an IO model. So in order to model such system, again, we will first start by expressing all outputs and demand in a common term in a common term or in a common form. And these are terms that have already been implied that are physical quantities because we've divided this through by the appropriate price per unit. So again, these are physical quantities. Okay? So in our assumption earlier, we have N goods. We also have N industries. Because we're strict with three sectors, we know that we have three goods as well. So again, we can just rewrite this one later on with X sub 1, X sub 2, and X sub 3. Okay? Again, restricting our study into three sectors and three goods. Okay. Now, in this case, class, we have a production vector. So these would be our values later on. This would be our production level of output for each sector. Okay. So again, I also will denote this one as our solved values. Again, if we have our inverse later on, we know that this would be our vector for production output. Okay. So sometimes when we have the input output table later, we can also call this one as our total output. Okay. And again, we will treat this one as non-negative values. So it should also be greater than 0. Okay. Now, the next thing is to define what the vector for the final demand is. So in this case, class, when you see final demand, this is the final demand. This is the total final demand for consumers or by consumers in money terms, and that is money terms for the output of industry. Let's just say industry or the manufacturing industry or either of these three sectors or industries in fixed, and it is fixed at D1, D2, and also D3 here. Okay, so now we've already defined our two vectors, again, the production vector, and we also have our final demand vector. Now, let's go over to this production coefficients or technical coefficients. We can also call this one, as I said kanina, our input. Let me just write it down. Input coefficients. Okay. So, right. Let me just delete the I first. Okay, but we'll go back to that one. So for the production coefficient class in an IO model, we can see here that, again, all the rules that we have applied last time, when we had a study for the inverses and also the matrices, the necessary condition should be a square matrix. Okay, so again, it could be a 3x3, it could be a 4x4. So this is just in a general form. But since I told you earlier that our study is strictly 3x3 or three sectors, then we will only deal with a 3x3 production coefficient. Okay. Now, let's look at closely at the coefficients. So as you can see here, class, these coefficients Aij, I would be our input, J would be I would be our input, J would be our output. So in this case, if that's A1, 1 would be input, another one would be our output. So what is the economic interpretation, or what is the Leontief assumption for each Leontief assumption for each coefficient here? So these coefficient could only be two things. This coefficient could be zero. This coefficient could also be positive. Okay, so or all these coefficients could be positive. Okay, so bakit zero? Bakit yung coefficient could be possibly zero? So in that case, if the coefficient is again zero, that would mean that that industry does not use or it was not allocated, or it does not use any input from a particular industry. So kunyari class, if you're looking at the if we're looking at the let's just say total output for manufacturing, tapos zero yung agriculture. So ang nangyayari is that um, we do the the output for manufacturing is not allocated to agriculture. Okay, so again, if you have a zero coefficient, that is just telling us that we're not using any input or output from a particular sector to one sector. Okay, but it is not another thing as well is if we have a positive coefficient, that is just means that the industries or the sector would require some of their own input to be used in the production process. So, for example, the manufacturing sector can use its own input to produce its own output. So, merong aside from we are interdepending with other sectors. The manufacturing sector is also allowed to use its own input to produce its own output. So, ganun. Now, what is not possible in arriving a coefficient matrix or this technical coefficient matrix is, again, it's an dapat na negative siya. So, we will not be, the assumption there is that you do, arriving with a negative technical coefficient would mean that it's economically, not economically feasible. Okay, so when building up with a coefficient matrix later on, it just means that either you can arrive with a positive value or a zero value or zero. Okay. What else? So again, I would insert I would interchangeably use these three terms, but all of them will refer to A as a matrix of production coefficients or technical coefficients. Okay. What else? Now, again, on this slide, class, this is just telling us that, again, this our Aij here is, again, the input coefficients. So this is the total money value of the output of industry I required by all industries. So for example, Aij there, xj. So again, let's try to disentangle each. Okay, so Aij xj, that is the money value of the output of the industry I required to produce xj of output of industry j. Okay, let me rephrase. So this tells us that the total value output of I that we will be using to produce this output or this good or commodity from industry J. Let me repeat. How much do we require from the output of industry I in order to produce this output from industry J? Okay, so again, this is what we call the total money value of the industry I required by all industries. Okay, what else? Now, in this slide as well, this is in total, this is the demands made on the output of all industries and can be expressed as this column vector. Okay, so this was our technical coefficients, and this is our total output. Okay. What else? Mm, each row here, class, each row here is the total demand on the output of the industry I made by the entire production sector. So the economy, but before that, let me just also uh, indicate that when you get the sum of these elements, class, so the sum of the elements in each of this column of the input coefficient matrix must be less than 1. If it is greater than 1, then the production may not be um, economically justifiable. So if you have a matrix later on, we'll need to check if the sum of these coefficients is less than 1. So dapat 0.9 siya. So if makikita natin ang mga matrix na in the problem set, those the coefficient corresponds to elements 0.3, 0.2, 0.1, because the important thing here is that it should be less than 1. Okay, so this again, uh, so these coefficients again are input requirements of each industry. Okay, so for example, in industry 1, you can actually because again, it's understandable that we're dealing with an IO model. So this would be industry 1, this would be industry 2, and this would be industry 3. So in that case, if you will be given an interpretation for each coefficient, you would say that in industry 1, this would be the um, input that would be getting from industry 1, input that we'll be getting from industry 2, and this would be the input that we're getting from industry. Okay, more of this one later. Okay, uh, going forward, guys, again, this is the um, observe here that again each row will correspond to the total demand. So if we have only x1 class, we'll have something like this. This would be the economy demand for the output of industry I in the economy as a whole, and also the same for this industry 2, also the same for industry 3. Well, if you try to again make this is just a summary, a summation of each total demand of for each sector. Okay, now again, input output model is used to correct output levels. So again, we need to stay consistent with all the input requirements that is needed in the economy. So for each if this is our demand for the output of industry 1 class or industry I here there, let me just go. This is industry 1. Okay. So if this is the total demand for the output of industry 1, it should also equate. We should have a supply, economy supply. So okay, remember class that input should be equal to output. If there is our total output here, our total we should equate it with to total input. Okay. Now let's go to this one class. Okay. Now, if all the demands in the economy are to be supplied, then for all industries or for all sectors, we can just express the vector of the total demand, X, as a fraction of the final demand, D. And the matrix of the inter-industry coefficients A would be equal to X is equal to AX plus D here. Now, again, let me just Robel. Okay, so this one here class just tells us that, okay, now this just tells us that economy supply or economy demand is equal to economy supply. So we can just express the values that we have defined earlier to get the industry coefficients. Now simplifying, this would be equal to X minus AX equal to D. We also know that simplifying this would be equal to the equal to I minus A multiplied by X equal to D. Now, this one if you're still familiar, class, this is again our identity matrix, meaning that our matrix coefficient, which we described here, which part? So, meaning that the technical coefficient, class, that we have discussed here is equal to I minus A. Okay, so that's just technically, again, technical coefficients or input coefficients is just equal to I minus A. Because again, equating or being consistent with the requirements and the outputs would yield equal to this. Okay. Now, let me just elaborate this part, class, before we arrive with our inverse or our Leontief inverse. Okay. So elaborating this part would be equal to this. Okay. So again, this part only tells us that in order to get the value of x, we need to get the inverse of that matrix. But because we know that this is not an ordinary original matrix A, we'll need to get the difference from the identity matrix. Then we will need to include that. Uh, we will need to include this one here into solving x. So therefore, class, simplifying here would give us, let me just also rewrite this as x values or x star here. So we're writing that would be x star is equal to 1 minus a raised to the power of -1 and multiplied to d. This is what we call now as our IO inverse or the Leontief inverse. Okay, so let me just write that one here. Okay, so this is our IO inverse or inverse or the Leontief inverse. Okay, so this would be our solution to get the production level that again equates both the output level and the input requirement. Okay. Now, before I proceed to an example, do we have a question? Do you have a question on the theoretical side of the Leontief inverse? Now, let me just repeat to this one, Tasha. This actually indicates that we're not looking for that optimization value. What we're only look after is that we're looking for that production level that is just sufficient to meet the input requirements, again, which is to equate it to economy, to the supply of the economy. Okay, so what else? Question? Okay, so if there's no question, I'll proceed to the first case or first example. So let's try to be specific on what we're trying to solve here. So we'll start first with how many industries that we are trying to interlink, or we're trying to explain the interdependency. So in that case, we have divided the economy into three sectors. We have agriculture, we also have manufacturing and services. Now, aside from that as well, the three industries will each use inputs from two sources. Either they use the outputs produced from these three industries. So this is what this one indicates that the services, in order to produce an output, might get inputs from agriculture, manufacturing, or even to its own industry. Or the services can also use inputs from other sources, which will have labor and capital. Okay, so this actually tells us that we are dealing with uh, an open model, because we are getting sources exogenously from others, or we're getting other sources aside from the ones that are produced in these three sectors. If this is a closed model, class, we'll be dealing with this one. Okay, again, if this is a closed model, the inputs should only be coming from these three sectors. But because this is an open model, we can also get other sources in the other sources in the economy, which is labor and capital. Okay. Now, in this case as well, the outputs of the industries have two broad destinations. So the output class can be allocated as an intermediate input or can also be used as a final demand. Now let me just delete some parts here, and then we'll go back to that. You just delete some. Okay, so I'll write this one again later. But for now, let's just say that the outputs for each industry could be used in two things, could be allocated. Okay, it could be an intermediate input in other sectors, or it can also be directly consumed, directly consumed by these other by the final demand of household firms and government, or um, household firms, government, or experts. So what's an example? Again, if manufacturing produces, let's just say, 100 billion pesos worth of output, then that 100 could be allocated. Let's just say 50 goes to the intermediate inputs. So intermediate inputs, this is used by agri. It could also be used by services. So 100 billion. So let's just say 50-50 sila. 50 is used as in intermediate inputs. So 50 divided by 3, let's just say, which means that I've included manufacturing, just to tell you that manufacturing is also using its own output. Or again, 50 billion is directly consumed by households, firms, governments, and exports, as measured by consumption, investment, and government spending, and also exports here. Okay. Um, let's go to this one here. Okay. Uh, Let me just also. Okay. Before anything else, let's try to define a lot of things here. Okay. Now, in the problem set, I am aware that I have not given any of these examples, but I want you to understand that the matrix A, which was the given in our problem set, this is where it came from. This is how we are trying to build the coefficient in matrix A. Okay, again, this is where that matrix is coming from. So supposing that we are trying to that we have an input output table here. Okay, so let's try to define. We have agri. So agri is again agriculture, manufacturing. Serve is services. Total intermediate demand is TID. So again, by the word intermediate class, it means that it is not the final usage. It is not the final allocation. Meaning it was used for other from other it is used by other sectors. So the total intermediate demand here is TID, meaning that this is the sum of 30 and 40. Okay? Balikan natin yung anong ibig sabihin ng mga numbers. But again, I just want you to first to understand where to locate TID. Okay, so TID is just the sum of 30 and 40. Okay, total final demand is 30. So as you can see here, class, we take this one as a given. So if we go back to here, okay, so asan na ba yun? So this one is TID, okay, and no, where is the here? Okay, so this one is TID. This one is to TFD. Okay, meaning TFD minus TID. Okay, so again, this one is our total intermediate demand. The final demand is composed or is constituted, no, it's a sum, no, it's the difference between the total final demand minus the total intermediate demand. Okay, no, let me just correct, TFT, so TFT, okay, so this is TFT, okay, so TFT, which means to say, okay, let me just correct here, total output is equal to TID plus TFT. Okay. So again, total intermediate demand is the inputs to production from other sectors that is used by other sectors, and total final demand is again the direct consumption of of household, firms, and government spending. So the total output class is just the sum of TID and TFT. Okay. So the total output here is 100. So that's 70 plus 30. That's 100. Okay. This one again, these are exogenous. So again, because this is an open model, yeah, it's an open Leontief model. Now, what else? Okay, the next thing is the total output. So that's TID plus TFT. We also have total intermediate cost. So total intermediate cost, so that is just the sum. That is the sum of these intermediate inputs, the cost of these inputs. So that's 30 plus 10 plus 20. So that's 60. So if we will have to, okay, so if we'll have to get a cost for all of these intermediate costs, we have TIC. Okay, so that's TIC in total intermediate cost. So that's 30 plus 10 plus 20. That's total intermediate cost. We also noted that this is an open model. So we have other sources of primary inputs. So this is, okay, so yeah, total primary inputs. Again, in order to produce an output, we need labor and capital as well. So we're getting them from other sources. And therefore, this will constitute as TPI. So total input. Okay. So in that case, class, total input is just equal. Total input is just your TIC plus TPI. Okay. Total inputs, that's 100. So that's 60 plus 40. Okay. Right. Now, let's try to understand how the coefficients class for each not yet the coefficients, but let's try to understand the numbers for each. Okay. Now let's focus solely on this 4, and specifically I want you to look at manufacturing. Okay. Okay, for a while. Okay, here. Okay, so take for example manufacturing. Its total output is 400. So the output is no, that is not physical quantities, but again in money value. So it's for manufacturing, its output is worth 400 billion, and it is allocated as follows: 10 billion is used in agriculture, 200 billion is used as an intermediate good for the manufacturing sector, 50 billion is used in the services or by the services sector, and then 140 billion is the final demand. So it means that 140 billion is used directly by households, households, firms, and government, and also exports. Okay. Let's go to agriculture. Okay. So if in terms of agriculture class, agriculture is its output is worth 100 billion, and it is allocated as follows: 30 is used by agri, so it is as an intermediate input for agriculture. 40 is used, 40 worth or 40 billion is worth or is used in manufacturing. And again, this is what I mentioned earlier, na pwede siya na zero. Okay, meaning that in the agriculture, in the output of agriculture, yung services, it was not allocated in services at all. Okay. So I'll do the same for services just to complete our analysis class. In this case, for services, it means that the output is worth 500 billion. Okay, so the output is worth 500 billion. It is allocated 20 allocated as follows: 20 is used in agriculture, 80 is used in manufacturing, and 200 is used as an intermediate good for services. Okay, so this is the explanation, or this is how do we the Leontief explanation for total output. Okay, so if there is no question, question. Okay, okay. Let's go to input. Let's go to input class. Again, starting with manufacturing. Okay, so now in this case, in order to produce, the manufacturing sector will use input worth of 400 billion. Again, in order to produce, the manufacturing sector will use or uses input that is worth 400 billion, of which 40 billion will be coming from agriculture, 200 will be coming from the manufacturing. Again, it is used as an intermediate input. 80 billion, or 80 is from the services sector, and 80 would be coming from other services, including import. Uh, including import, labor, and capital. Okay, let's do the same for the other three. So for agriculture class, so for agriculture, in order to produce, the agricultural sector will need will need to use the will need to use an input worth of 100 billion. So it's in order to produce in agri, it should be getting, or the input that we'll be using should be coming from 30 from agri, 10 from manufacturing, and 20 to services. So I think you see the pattern already. So you can just do the same for services. Again, just still pertaining to total input. Okay, so if you take a closer look on this side class, so the total output 100, 400, 500 respectively for each sector. We also have 100, 100, 400, and 500. This only tells us that the sector output should be equal to sector inputs. Okay. Okay. Now, moving forward, the next thing to do is we define the following vectors. Just like what we've explained earlier, we'll need to define what are those the vectors of final demand and the vector of total output. Okay, so D here, constant D, is equal to 30, 140, and 200 because we take this one as given. It's exogenous to the model, and this is the vector of final demands. So the vector of final demands are, again, those are consumed directly by the household, firms, and government, and also exports. Okay, X here is our total output. This is the vector of total output of the industry or the of the industry sectors. So total output again is TID plus TFD. So again, that's 140 and 500. Okay. So again, these are our column vectors, and we'll be using the later when we're getting the inverse. Okay. Question before I proceed to getting the input-output coefficients. All right. Now, the next thing to do here, class, is we need to derive the input-output coefficients. Again, we mentioned in our basic, so we mentioned here in our assumptions, which is it's a critical assumption that it should be a fixed technical coefficients, meaning that calculating IO coefficient will need to divide each element in the IO table by its column total. So again, it's a fixed proportion. So in that case, class, let me just delete this. Oh yeah, all right, we can use that one and not use here. Okay, so we're now deriving the IO coefficient. So let's have this one, okay? And we'll need, because it's fixed, because again, that's one of our assumptions earlier, um, we'll need to divide each element in this table by its column. So that's 30 divided by 100, 10 divided by 100, 20 divided by 100. The same for this, also this sector as well. So that's 40 divided by 400, 200 divided by 400. Also for services, that's 0 divided by 500, 50 divided by 500, and 200 divided by 500. Now in build, so this will now help us build or write in matrix notation the matrix of inter-industry coefficients. But before that class, again, you can just get this one here, okay? Just to give you the inter-industry coefficients, okay? Now, then, but before that, let's try to make an Leontief explanation for each coefficient here, okay? So, suppose we're getting this, okay? So, what does this tells us? That the value of the input that is used by the agriculture class, 20% of it 20% of it comes from services. Okay, so again, doing the same for agriculture class, the input or the value of the input that is used by agriculture, 30% comes from agriculture, 10% comes from manufacturing, and 20% comes from services. So how did we arrive at the percentage? So that's 30 divided by 100 times 100. So 30% came from agriculture, 10% came from manufacturing, and services, 20% came from services. Okay, so again, we're now building the input-output coefficient matrix. And so let's just highlight this so that we'll not get confused on what numbers to use or what figures to use. Okay, so in this case, this would be our matrix A, later. So this would be a matrix A here would be called as the IO technical coefficient matrix. Okay, so again, simplifying this would yield this matrix of inter-industry coefficients. Now, in your problem set class, if you have noticed, what I only gave you is this one here, and also the vector of total final demand. I want you to understand that the discussion here is actually how did we, or where is this, saan nanggaling to? Okay? Sa akin kasi, we take this one as a given, but this matrix class is coming from this one. This matrix is coming from this one as well. So it's an entirely, there is a process that is not explained in the problem set, but the matrix that you have in the problem set comes from a series of deriving this table. Okay, great. Now, when we already have the matrix coefficient, we already have the IO technical coefficient matrix. The next thing to do is we need to solve for the IO inverse. Now, the IO inverse class is also called the Leontief inverse matrix. Okay, so again, in a typical matrix class, what we did was again to get the matrix of the original, to get the inverse of the original matrix. In this case, what sets it apart aside from the economic analysis is we need to get the difference between difference of I minus A. Okay, so in that case, with this original matrix, we'll need to get you'll need to subtract it. We need identity. So that would be identity matrix minus the original matrix. We'll not call that one original matrix. That's identity matrix minus the coefficient, the technical coefficient matrix equal to this one here. Okay, so this will now be we will be using. So this will be the matrix that we'll be using to get the Leontief inverse. Now, again, since we are still getting the inverse of that matrix, we follow the same procedure with getting the matrix or matrix inversion. Okay, So let me just go through to that one. Okay. So let me explain some parts here. So the first thing we do is we build an IO table. Again, we're done with this one. These are just the coefficients in decimal format. The next thing we did was we get the IO technical coefficient. So IO technical coefficient, these are this. Let me just go to IO. Great. So again, this is the IO technical coefficient matrix. And then on this side here, because we're getting the inverse, we're also getting first the cofactors. So in order to get the cofactors, we need to get the matrix of minors. Okay, so that's minors, and then get the cofactors. And also, after getting the cofactors, you get the adjoint matrix, and this is our adjoint matrix. Now, this part right here, class, I'm just getting the determinant of, again, the determinant of this matrix here. Okay, take note na this is Leontief inverse. So if you're getting the determinant, okay, so if you're getting the determinant, it is not the determinant of this matrix here, but rather I minus A. Okay, so what else? After that one, the solution, since you'll have the inverse already, class, but typically, if it is just the typical inverse, we will need to multiply the inverse to that of the original matrix. I mean, to that of the constant vector D. In the Leontief inverse, class, we'll do the same. We will also multiply it to the vector, which is the total final demand vector. Okay, so in that case, let me just go through over this one. The solution system would be equal to this. This is our inverse. This is our Leontief inverse. So Leontief inverse again is I minus A raised to the power of -1. We multiply it to D. D here is our total final demand. And this one is our total output. Okay. So I think I just put here, how did we arrive with 100? So that's 148 times 30 plus 0.39 times 140 plus 0.053 times 200. Now take caution, just to take caution, class, do not round it off unless it's the final answer. For example, if this is your final answer, um, if this is your inverse, uh, if these are your figures, class, do not write it yet as 1.48 because you will not yield a specific value for the total output. So again, only round it off when it's the final answer. Now, for the final answer, you will need to round it off to 4 decimal form, yeah, 4 decimal points rather, and yeah, to arrive with an answer. Okay, so let's go back to the solution system. Okay, so again, this is our Leontief inverse. Is our this is our total final demand. Take note, class, that this seems to be a bit familiar. This is our total output. So along the way, class, that we are solving for that production level, we already have an answer. Okay? So hindi mo pa siya sinosolve, alam na natin that the production level is equal to 100, 200, 400, and 500. Because again, your input should be equal to your output. Okay? So now, what is again the point that we're making here, even given that we already know the answer? The thing is, this is just to validate, to verify that our inverse is indeed our inverse is indeed the Leontief inverse. Okay, because again, it will yield the same value as our total output. Okay. Again, this is our input requirements. Okay, let me put that one on the side. So this is our input requirements. Input requirements should be equal to your total output. So this inverse right here multiplied to the constant would equal to the total output. Okay, input equal output. Okay, so uh, right. Now, because we have assigned this one class as our, let me rewrite also, okay? So again, because this is sector 1, sector 2, and sector 3, ano, so this is uh, W's, agriculture, manufacturing, and services. So what does this tells us when it comes to economic interpretation? So agri, let's just put that on the side. So that is agri, man, and services. Okay. So in that case, we can just say that the agricultural industry should produce 100, let's just say, billion worth of output. The manufacturing industry, uh, manufacturing industry 400 billion worth of output, and the services industry will produce 500 billion worth of output. So in the problem set, as what in the problem set, you can just inform me what are those, what are these numbers are, and also inform me what are these coefficients are as well. Okay, so for example, again in sector 1, uh, uh, yeah, I'm actually aware, class, that I did not indicated it that it's an industry 1, manufacturing, agriculture. But because we again will already have restricted it that there's only 3 industries, you can just assign them one as industry 1, 2, and 3. And later on in the economic interpretation, you can just say that their services, or let's just say that industry 2 represents 10% of its total output for agriculture. Okay, or no, not agriculture, but industry 1, or um, uh, industry 1 uh, will be getting 30% from its own industry, 10% from industry 2, and 20% from the third from industry 3. Okay, so either you interpret this one here, or the coefficients in that matrix, or you interpret this one here. Okay, both should be present in the economic interpretation. Okay, all right. Okay, so question.
Ma'am,
Yes.
ma'am, can you please run through again the process? Ma'am from the first. Ma'am, just quickly, ma'am, so that we could consolidate it.
Okay,
Na
good.
our
All right, thank you. What do you mean process this part here?
Yes,
Okay.
ma'am. Ma'am, just quickly.
All right, sure. Okay. Now, in terms of the process, class, there's no definite process because it will depend on which of what is given. So if your given is similar to this one, wherein you will still need to derive your coefficient matrix, we'll do a similar process to this one. Okay. So the first thing that we'll need to do is to uh, to have an input output table to understand what constitute or what numbers that you will be using. So normally, I'll just give you an input output table, and you will need to identify what uh, what are those numbers that you need to get the matrix of inter-industry coefficient, or the IO technical coefficient. Okay, so from there you also need, the next thing to do is to define the following vectors. You'll need to get a vector of final demand, which is your total output. You will also need to get the vector for total output. Okay. So in terms of, again, processes, step 1 is to get this vector. You'll get, this would be your vector D. So I just put a parenthesis plus, actually it will be an incorrect. That's just me. That would be vector D here, small letter D, and this would be our vector x. Okay, so again, define this one. Uh, Let me just delete this first. Okay, all right. Define this. So again, when you say define, you can just rewrite this one in matrix form. So this is vector D, this is vector X, okay, or total output. Okay. Now, the next thing to do is to derive the input-output coefficients. So that would mean that you will need to divide each element of these, yeah, divide each element to the column total. So let's have this one in green. Divide that each element to the total input, or to the column total. So that's 30 divided by 100. 40 divided by 400, and 0 divided by 500, and you do the same for the other sectors. Okay, so again, all these in the ones that are in colored class, these are the ones that I am using to write, or to be it in matrix notation. Okay, so now, so if again, uh dividing each element will have this, from the IO table, you will need to simplify it in order to write it in matrix notation. Okay, so again, so that's 30 divided by 100. It would be equal to this matrix here. Okay, now again, you can use either the fraction or decimal point. But if you're not careful with just with the decimal, you can just go directly with the fraction. Okay? Kasi it might be an instance na you would be rounding it off without being you'll round it off even if it's not a final answer. So if that is the case, then just use the fraction. Okay? So after, again, the yellow one here indicates that this would be our IO technical coefficient matrix. Okay, so that is our matrix here. Now in the problem set, this is where you will start. Okay, so again, because the matrix is already defined, the column vector, the total final demand vector is also defined. Okay, now the next thing to do here is you will need to get the Leontief inverse matrix. Leontief inverse matrix tells you that it should be I minus A, meaning that um, subtract this with our identity matrix. So that's I minus A, and this would be our Leontief inverse matrix right here. Okay, so now, are we done yet? We're not done yet kasi we still need to get the inverse of the Leontief inverse matrix. So this is our Leontief inverse, and the next thing to do would be to solve it uh, by just like the regular process of an inverse. So again, this is, let me just put some label. Okay, let's have that one as our Leontief inverse. Okay, so let's have that. Let's define that one. So, okay. Anyway, let me just write on this side. Okay, so this would be our Leontief inverse. So inverse. Okay, so if we'll still be following, let's have this one as step 5. Okay, Leontief inverse. Okay, no, step 4. So this will still be step 4. Okay, uh, step step 5, step 5 to 1, step 5.2 is a matrix of minors and matrix of cofactors. Okay, so again, step 5 is just to get the matrix of cofactors, but you know that getting the matrix of cofactors would mean to get the matrix of minors. Okay, so this is our cofactors already. Okay, um, step 6 is to get the adjoint matrix. Okay, so adjoint matrix is just a transpose of your cofactors. Okay, in this case, class, this is already the part step 7. I did not include any more class on getting the determinant because you already know how to. So step 7 is getting the yeah. Matrix, and you'll get here your Leontief inverse. inverse matrix. So step 7 again is your solution value. This would be the inverse that you will be multiplying to get the solution value. Okay, so again, getting the inverse would mean dividing each element, no, getting the inverse class would mean that your determinant is, suppose this is your determinant, you will need to multiply it to every element of the adjoint matrix. Okay, so again, remember this was our discussion on adjoint. So it's just the same as Leontief inverse class. So if you have a determinant already, that is again multiplying it to every element of the adjoint matrix. So that would be your inverse. So that's okay. Now again, this is already your inverse. So let me just so you already have your inverse. Step 7. So step 8 would be your solution value already. So step 8 is get your solution value. So this was our inverse. Okay, so this was our inverse. Multiply it to our constant or to our total final demand, and your solution value would be your total output. Okay, so yeah, in terms of process, let me go. So step 5 is actually step 5 to step 8 is showing that in order to get the solution value for x, you will need to multiply it. You will need to multiply the Leontief inverse to that of the total final demand. Total final demand D or vector D there. So that is your that's basically the process. Okay. So again, the process is the same. It's just that it will depend on which you would start. Well, I'm not really sure if that is the formal way how to do it, but if I will try to make an outline, it will really depend on what is given. So if you're only given onto this part, you can just go ahead and start with step 4 and to going to step 8. Okay. Now, what else? Okay. Now, actually, class, I started off first here in our first case with an input-output table. There are also instances that I'll be giving you a case like this. Okay, so case 2 class. So this is case 2. This is case. Okay, so this is case 2, and I might call this one as step 0 if that will if that is well, step 0 if we will following the same outline here. Kung ito yung step 1, ito yung step 0, because this is a word problem that we will need to so if this is step 0, which is a word problem, you will need to identify as an input output table that is equal to this. Okay, so again, but then again, the process is the same. Okay, so I'll discuss this one next meeting, but for now, the process would be equal, or the input output model is follows the same patterns as this one. So yeah, I think that's it. Questions, class? So in your problem set, uh, please focus first on getting the value for the inverse, meaning that practice first on what is the process that you will need before I give you this one. Okay. Uh, okay. So I've been told that you have problem 12. Let me pull quickly what is problem 12. I've been asked the same question earlier, but I actually forgot what is problem